All right, we have an exciting session ahead where we will be exploring the fundamentals of DAX. DAX stands for Data Analysis Expression. Let me give you the outline about what we are going to take a look at it today. In today's session, we'll be focused on these topics. First, we'll start with the introduction to DAX, and then we'll explore what is DAX and why it is essential in the field of data analysis or the business intelligence. Next, we will delve into the X velocity engine. We'll understand how this powerful. It is an in-memory analytics engine. Okay, how this engine drives the performance of DAX, and also we'll explore its capabilities in processing and coding the data and how it enhances the speed and efficiency of calculations on large data sets. Next one is the operators and data types. Moving on, we will dive into the operators and data types in DAX. We will also learn about various operators available for performing calculations and comparison. And then, if time permits, we'll discuss the arithmetic operators for basic mathematical operations and the comparison operators for making logical comparisons. Okay, additionally, if time permits, we'll explore the different data types supported by DAX, such as numeric, text, and Boolean. So let's dive in and explore the world of DAX together. Okay, what is DAX? I told you DAX is DAX stands for Data Analytics Expression. Okay, so DAX is nothing but the set of functions, operators, and constants that you can use it in formula. For example, you want to perform some kind of data analysis, which involves some kind of business logic. Okay, based on some business logic, you derive some columns, or you want to implement some logic based on which you want to do the data analysis. So in that case, the DAX is very much helpful. The DAX is not only available in Power BI. So you know very well in Excel, we are using Power Pivot and analysis service also it is available. Okay. Using DAX, we can perform calculations, aggregations in simple term. Okay. And transformation of data in tabular models. Okay, and these are things that you can do it. It is not only used in Power BI, like I said, it is used in Excel, Power Pivot, SSE, tabular edition, Azure analysis services, and DAX can also be used to filter or query a physical table. Okay. Next one is the so why to use DAX? Why to use DAX? So it's simple, and it's a very simple question. If you wanted to reuse a formula in multiple places, okay, in that kind of situation, the DAX formulas are very much helpful. You can create a measure. There is something called measure. You can create a measure. Once you create the measure, you can reuse it as many times as you want it. And also, if you want to create a complex or customized formulas, where you cannot always use sum or average to solve certain things, right? So in that kind of situation also, DAX is very much helpful. Using DAX, we can get the most out of our data. With the, what do you mean by most out of data? It's not macros, I did not use it much. Okay, it is maybe right. Even in Excel, you have something called Power Pivot. And in there also they are using DAX. Okay, but I cannot, I don't know if these two are same. How good are you with macros? How good are, okay, fine. So that is a different thing altogether. See, the so in the case of macros, right, both of them, the DAX and Excel macros, both of them serve different purposes. Okay, and also it operates in different ways. Okay, it is not same. DAX is you just think it's a formula language, primarily used for creating custom calculations, aggregations. Whereas in Excel macros, the scripts are created using VBA that automate the repetitive tasks and actions in Excel. Okay, that is what as far as I know, this is the difference between these two. Okay, but these two are not same. It is meant for a different purpose. So, for example, you have created a measure something. For example, here, on the left side, you can see total sales. This is a measure. On the right side of total sales, you can find the equal sign. And on the right side of the equal sign, you'll find the sum function. Sum is the aggregated function, DAX function. Inside the sum function, I mentioned the column name here. So what it does is, it computes the total sales. That output will be made available as part of total sales. But remember that once you create a measure, or as soon as you create a measure, you cannot see the value, you cannot visualize the value of the total sales in this case. Okay, only when you drag and drop this measure into a visual, we can find the value. So we can see the value. Okay, see the whole advantage is data is available, everything is available. If you are given an opportunity to, or the flexibility to do a deeper analysis, the more the analysis you do, you will get more insights. With those insights, you can fine tune your business strategy, right? Marketing strategy, sales strategy, right? And even when to spend more on your, in your campaign, all the things you can do it. Okay, whether my campaign led to any increase in sales or something like that. Okay, so where are DAX formulas are used in Power BI? The calculate tables, calculated columns, measures. Remember this is very important. Calculated tables, calculated columns, and measures. But these two are very popular, the calculated columns and measures. At times, you'll be using calculated tables also. Okay. So Power BI support two languages. So now the question is, what is the difference between DAX and M language within the Power BI itself? We have seen what is M language at a high level. In Power Query Editor, we have something called M language. Whatever you point and click it creates the step, right? So that steps, if you click on it, you can see some DAX functions created behind the scene. On our behalf, the Power Query Editor generated the M script or M language. It is also called as a mashup language, okay? But mashup language or the M language is different from DAX, and these two cannot work together. You cannot use these two functions together. And M is different, DAX is different. The M script or the query, you can use it only in Power BI query editor, whereas DAX is an analytical data calculation engine, and M and DAX are not dependent on each other. It is independent of each other. Okay. So next one is the DAX engine. Okay. The DAX formula, look here. So I mentioned a simple formula. Total sales is equal to sum of financial sales, right? That is your DAX query. The DAX query is processed by two engines. What are those engines? The one is the storage engine, other one is the formula engine. These two are the art of your DAX engine. Which one? The formula engine and storage, and these two are art of your DAX engine. It evaluates your DAX formulas and expression to calculate results. Remember this, okay? So these formulas, you can use it in calculated columns, calculated tables, and measures also. The formula engine is responsible for handling calculation and aggregation at the row level, whereas the storage engine is responsible for optimizing your query performance. It manages data storage, compression within the tabular model. And also the storage engine, it caches the pre-aggregates data to speed up your query responses, okay? For example, this is your DAX query, total revenue in Chicago. On the right side of the equal sign, you can find the calculate function. Here, you want to find out the total sale in Chicago. This is what the DAX query, you have written it as part of your measure. Once you write a measure and when you drag and drop it in your visual, what will happen is behind the scene, there is something called formula engine. It accepts this DAX request and then it processes the DAX request. Okay, and it accepts this one and then it processes the thing. And next thing is it generates a query plan. Okay, it generates something called the query plan. It's kind of a, the map, the Google map. It's kind of a, the query plan is kind of a Google map. You just think that way. Okay. The formula engine is in simple term, it accepts your DAX query and processes the query and generates the query plan. That's it. So in the case of import connection mode, what happens is the formula engine, it sends a data request to your storage engine. Query is there, fine, but data is required in order to execute the query, isn't it? So what happens is upon receiving the query from the user like us, it does all the things, generates a query plan. And supposing this query, which you are firing it against the table which you have used the import mode, in that situation, there is something called vertipack or X velocity engine comes into picture. What it does is it performs three actions. One is it translate or transform. It transform your table or data into columnar database. And second thing is it compresses the data, and third thing is it loads the data in memory. Very simple. Which one? The X velocity does this job behind the scene in the case of import mode. I think I did not put import. Yeah, in the case of import mode, that is what is happening. Okay. What is vertipack? Previously, they call X velocity as a vertipack. Now they renamed it as X velocity. Okay, got it. So what is query plan? See, query plan is something like it's like I said, it is like your Google map. So what it does is the formula engine generates the query plan. This query plan aids the storage engine how to get the data from the data file. Okay, you just think that way. Okay. So this is this is how it works. Okay, fine. And in the case of direct query mode, let's say your data is stored in SQL or Oracle server and you use the direct query mode. So in that case, what happens? The same thing, the query plan will get generated. But in the case of direct query, the query plan will be sent directly to a SQL server or Oracle server, and then the query will get executed here. The output of the data will be sent back from your SQL server to your formula engine. Whereas here, the X velocity does these three steps. It caches the data in memory, and then the cached data will be sent back to your formula engine in the case of import. That's all. If you remember this much, that is enough. So, okay, next question. Now the question is, okay, the vertipack, the X velocity, why it performs these three tasks? First of all, why it has to convert the tabular data into columnar data? Because the columnar data or database are gaining a lot of popularity, especially in the world of big data. The columnar databases gain a lot of popularity. Because nowadays the volume of the data are very, very huge. We are not working with smaller data. We are working with petabytes volume of data nowadays. So in that case, to optimize the performance, they develop something called columnar store. For example, Apache, Cassandra, HBase, and the MongoDB, MarkLogic. These are the NoSQL database. Okay, so in that case, they store each column separately. Those are called as a columnar database. The idea is pretty simple. If you store each column separately, for example, you want to access in your query name and unit price for camcorder and smartphone. It goes directly to the name column and then unit price column. It's like a separate table. Each column is considered as a separate table, stored separately. Okay, hence the performance is pretty faster. But in the case of row store, what happens is if you have multiple columns are there, but all you need is to your report, you need only these two columns. And it goes and checks in the case of roster, where is name is there. Name is not there, not there, not there. It has to skip until it finds the required column in your row store. If you have humongous amount of data, if it skips the columns and until it finds the required column, it takes a lot of time. That is the reason why columnar databases came into picture. It is pretty faster. Whatever the columns you wanted, access only those columns directly instead of going and skipping and searching the columns, right? Better you go directly to the respective column and then go and fetch the data. That is what the whole idea of columnar store. Okay, once you get the data, you compress the data and then load the data in memory. Since you are compressing the data and loading in memory, the compressed data, if you load it, the performance will be, it doesn't require too much of RAM, right? It doesn't require too much of RAM to hold that data. For example, your Excel file sizes 1 GB, and if that 1 GB file get compressed as 10 MB, it is far better, right? It compresses that that much level. And if you load just only 10, you just assume that if you load 1 GB data into a memory, it requires 1 GB RAM, the performance will be slower. If you are owning just, let's say you have just 4 GB RAM, out of which 1.5 GB RAM is required for loading your operating system, performing operating system tasks. We are left with just 2.5 GB RAM. Okay, but if the memory consumption is very less because the data you are loading a compressed data, hence the performance is faster and it doesn't require too much of RAM, RAM also. So that is what is taken care automatically by the X velocity engine. X velocity engine. Okay. In the case of import mode, direct query, it is straightforward. It goes and directly executes. Okay, next question is, okay, in the case of X velocity, it does the compression. On what basis it does the compression? It's kind of a zipping, right? Windows zip, WinZip. How it compresses, what kind of technique it uses. So in this case, right, it uses something like value encoding, dictionary encoding, and run length encoding. Value encoding is used on integer values. Let's say your columns are integer, numeric. In that kind of situation, value encoding is used. If you have a text column, dictionary encoding is done. And there is something else called RLE, run length encoding. What it does is it goes and checks for repeating value. It codes a column that is value encoded, dictionary encoded. That's it, guys. Okay. So what is value encoding in DAX? So the value encoding is done by X velocity engine for the integer values. For example, if you see here, these are the values stored in your column. Okay, what happens is, what is the maximum value? 216. It requires 8 bits needed in this to store this data. And what it does is, in the case of value encoding, it finds out the minimum value. It subtract the minimum value from each and every value. First, it finds out the minimum value. What is the minimum value? 194. If you subtract 194 from 2 and 2, you get 18. If you subtract 194 from 194, you get 0. So 197 minus 194 is 3. It finds out the minimum value, subtract the minimum value from each and every value. Finally, you will end up your value something like this. And if you see the maximum value, just 22. And to store these values, it requires just 5 bits. You might be finding it is a insignificant value, but when it comes to humongous amount of data, for example, you have 10 million records or 100 million records, 100 million into 3 bits. If you save it, how much? 100 billion into 3, how much? 300 billion bits you are going to save it, right? So here, this is how he is doing the value encoding. This is the whole idea. This is the idea of your value encoding. Okay. Next one is the hash encoding. This is for text data set. For example, in your data set, you have a column called color. Look here, column called color. The color you have red, blue, white, black, something is there. This is your original column. Okay. So in the case of import mode, the X velocity, what it does is it builds a dictionary something like this. In this dictionary, it takes the unique value of your color column, red, white. Instead of, it removes the duplicates, and then it puts the unique value in the color column, red, white, black, blue, and it assigns the integer value in a sequential manner. Red, the integer value starts from 0, 1, 2, 3, something like that. And then what happens is it replaces these values. It replaces these values by 0, 1, 2, 3. 1 second. 0, 1, 2. Look here, red is meant for 0, and white is 1, and black is 2. So black is 2. Okay. So it simply replaces the text value by the index values. Okay. That is what is happening. Red is 0. Look here, 2 red is there, 2 0 is there. And if you see net, the size of this one is pretty small, right? In this case also, you can see a lot of space. It automatically saves this space, okay, using this dictionary encoding. And next one is you have something else called run length encoding. In this case, it is looking for the repeating values. It codes a column that is value encoded for dictionary or encoding. Look here, in this case, you have a quarter column. In this quarter column, I can see the Q1 is repeating multiple times, Q2 is repeating multiple times. How many times the Q1 is repeating? Already they've given 310 times. Q2 is repeating 290 times. So in this case, what it does is in the quarter Q1, it simply it starts with 1 and ends with 310. That means starting from first record to 310, the record, the Q1 is available, repeatedly displayed. The same thing is applicable here. So what happens is it smartly uses the combination of run length encoding and the dictionary encoding. Again, so Q1, Q2, Q3 is there, right? Here, in this case, in the quarter, we can see Q1, Q2, Q3. And here, what happens, the dictionary cache, right? So in this case, hash encoding, okay, what does is, it take the unique value, Q1, Q2, Q3, Q4, and it assigns the integer value. And then each integer value, it gets mapped with the repeated number of repeated value. 0 means Q1, 310 occurs, that many number of times 0. No, we don't have to do it. It is all taken care automatically. Okay. That's what I said, where the X velocity engine does the compression. For us to understand how it does the compression, I'm explaining it here. Okay. And if you see the original data here, all the Q1s were repeated by 0 and Q2 by 1. Okay. And okay, so now so this is how it works. Okay. Now the question is, okay, if it is taken care automatically by X velocity engine, why should I know about this? Because the interview they'll ask you, right? Not only interview point of view, from the performance point of view, you should be knowing it, right? So how it, for example, you want to fine tune certain queries, it takes longer time. So you want to fine tune that query. In that kind of situation, you should be knowing what is happening behind the scene, right? To summarize, DAX uses 2 engines, the formula engine and then storage engine. and then the formula engine interprets and evaluates your DAX, and the storage engine compresses and encodes your data. Okay, and there are two types of storage engines. One is the Vertipack or the X-Velocity, and then the direct query. X-Velocity engine gets started. It gets kicked in when you use any data in the import mode, storage mode. Okay, and then in the case of direct query mode, also the storage engine comes into picture. Okay, and Vertipack or the X-Velocity is used for in-memory storage. Okay, and the direct query is for direct connections to external sources. Okay, both create data caches and send them to your formula engine for DAX query evaluation. Next one is the Vertipack stores data using a columnar database setup. Okay, data is stored in individual columns. Instead of using the row store, each column is stored separately. Okay. And then what it does is the raw data is compressed and encoded to optimize processing. So you should be knowing the DAX engine's functionality. How does this DAX engine works, right? There are two components, the formula engine and storage engine. Within the storage engine, you have something called X-Velocity and direct query. That's all. Okay. So this wraps up the X-Velocity engine.